Hey guys, welcome back. Hope you all are doing well. Today we are gonna see another lab from HTTP Request Smuggling vulnerability module, and in today's lab we are gonna see response queue poisoning via H2.TE Request Smuggling. So the description of this lab is saying this lab is vulnerable to request smuggling because the front-end server downgrades HTTP version 2 request even if they have an ambiguous length. And to solve the lab, we need to delete the Carlos user by using response queue poisoning to break into the admin panel @admin. And an admin user will log in approximately every 15 seconds. So the connection to the backend is reset every 10 requests. So don't worry if you get it into a bad state, just we need to send few normal requests to get a fresh connection. So in some conditions, if you stuck and you think the application is not responding as expected, you need to send the normal request 10 times and then it will reset the connection and give you a fresh connection to test. Okay, now in this lab we actually exploit the HTTP request smuggling in a HTTP version 2 environment, specifically an H2.TE vulnerability. So what makes this lab interesting is the front-end server, this part. The front-end server accepts HTTP version 2, but it downgrades requests to HTTP version 1 before forwarding them to the backend server. And it does it even when the request length is ambiguous. Okay. So this downgrade behavior allows us to smuggle requests and ultimately perform response queue poisoning, which we use to hijack an admin session. So this is what makes this lab more interesting. Here you can see this is our lab and all the requests going through the burp proxy. I don't need all those requests. I'm gonna clear history and just gonna refresh the page again. Now the key concept of H2.TE request smuggling here is transfer encoding chunk. Okay, because HTTP version 2 does not use or interpret transfer encoding. However, in this lab, the front-end server incorrectly accept a chunk HTTP 2 request and downgrade it to HTTP version 1, and the backend processes the chunk body differently. Fine. So this discrepancy or mismatch allows us to inject extra data into the request stream, which the backend interpret as part of the next request or the future request. Fine. So I send the request here. This is our request and I'm going to send this request to the repeater. Go to the repeater. And here we need to again see a few things, because according to this lab, because the front-end server accepts HTTP version 2, so make sure it's here version 2. Second thing, I don't want the content length to be updated automatically. So these two things are important for this lab. Next, I'm gonna change the request method and I don't want all of this. Now again, to make sure whether the front-end server accepting or interpreting transfer encoding, so for that purpose I'm gonna add here transfer encoding header, and the value of it is gonna be chunked. Fine. Now again, to test this, I'm gonna add here, let's say the chunk size is 4 and add the chunk data, which is 4, and an invalid chunk size, which is, let's say, Z, because in hexadecimal there is no Z. Okay, fine. Now let's see if the front-end server is using chunked encoding. That means it will interpret the chunk size, then see the chunk data, and then go to see the another chunk size. Because the chunk size is invalid, so we will get here invalid request. If the front-end server is checking content length, then it will see the content. So let's see, I'm gonna see what is the content length. Let's say the content length is 7, so I'm gonna update it to the 7. But so the 7 is up to here. Okay, or we can add it up to here. Let's say I'm gonna say here 9. So this is gonna be the next request. Fine. So let's see, if the front-end server is using content length, we should get here communication timeout. Otherwise, in transfer encoding interpretation, we will get invalid request because the hexadecimal chunk size is invalid. So send the request, and you can see invalid request. Even if you change the content length to 100, you will get invalid request. Even when you put the chunk size of 7, you will get invalid request, because the front-end server is not interpreting the content length, it is always checking the chunk size. So this is the first thing. The question arises why this leads to response queue poisoning. So instead of directly attacking the admin panel, we poison the response queue. Okay, response queue poisoning means we manipulate how request and response are paired so that one user receives another user's response, that we did in the previous labs too. So in this lab, an admin user logs in every 15 seconds, making it possible to capture the admin's post login request, then steal the session cookie of the admin and access the /admin endpoint. Fine. Now, before going to do that, I'm just gonna do here one more thing. So the chunk size 0 means message ends here, and then I'm gonna put here a get request, and let's say I'm gonna say nothing, an invalid endpoint, and HTTP version 1.1. Fine. Next thing, I will put here the host header. So this is gonna be our host header, and no need for the transfer encoding header or the content length header. That's okay, fine. Even here, because we already confirmed that the front-end server is not interpreting the content length, so even in the first genuine request, we do not need the content length and content type. Okay, because we know that it's using transfer encoding. And here you can see this is the new line trails, and that seems perfect, but this one is not, this should not be here. So I'm just going to delete it, and fine. Okay, so wait, let me just make it like this. That will be okay. What we are gonna see here, if we send the request one time, we will see 200 okay, and if we send the request second time, we should get not found. Okay, that means the smuggled request is working perfectly fine. Now in this case, in every second request, once you send, in every second response, you will get 404 not found. Okay, so this alternating behavior confirms that the backend server is appending the next request to the smuggled prefix, and the connection is desynchronized. Okay, so what happened when the admin user log in? The server responds with 302 redirect here and sets a new session cookie, and that session cookie we need to confirm. So let's just send the request few times, 200, 200, 200. Why so? 404 not found. So what I want is to get every request as 404, so that we can easily identify or capture the request or victim user response here. Okay, because we are poisoning the response queue. So just send the request. Once you get 200 okay in the response, and now every time when you send the request, you should see here anything you get here 404, that always return 404. This is your own request, and any non-404 response must belong to another user. That means 200 okay or 302 found. Okay, let's see we get here admin or not. So 0 match. You need to send request multiple times. Every 15 seconds the administrator log in. So up to now we should get 302, but if we didn't get, let's see, change something here, a different endpoint, let's say from nothing to no. Send the request 200 okay, 200 okay, and 404. So what's actually happening, let's see, I'm just going to refresh this page and see how application is responding. So I'm refreshing basically the home page, right? The web root page. So refresh it one time, not found. Okay, expected, expected, expected. Okay, fine. So we are sending the normal request 10 times. And back to the burp proxy. And here I'm going to send this smuggled request one more time. And you can see here we got 302 found. Okay, so this is for the administrator. You can see ID is administrator, and what I can take from here is the session cookie. So I'm just going to send this request to the repeater, and then I'm going to take all of these requests from here and make sure the HTTP version is 2. Okay, and then I'm gonna add here the session cookie. So from here up to here, copy and paste it here, and instead of no, I'm gonna try to access admin endpoint and send the request. Okay, 200. Okay, let's see if admin panel is here. No, it's saying login. Okay, now here we have the admin panel. So you can see we can delete the Wiener user and the Carlos user. So let's see, I'm just going to take from here to delete the Carlos user, copy that and paste it here in the endpoint with / and send the request to delete the Carlos user. 302 found. Back here, and you can see we solved the lab. Now if you want to check out the response, so follow the redirection and show response in browser, copy that, back to the browser, paste that, hit enter, and you can see there is only Wiener user and the Carlos user is successfully deleted. So that's it for this video. I hope you enjoy the content. If you like the content, please like, subscribe and share. I'm gonna see you in the next video. Bye.